Mr. Lassard coming at you with your part 3 of your distance learning assignment for this week with the learning target that you're going to conduct that inquiry that you did in part 2, and then you're going to apply knowledge gained from that inquiry into a scientific explanation that we're going to find here. So I've broken it up into parts A, B, C, D, and E. I want you to write your response in separate sections. And in part A, you are just picking one of these organisms that you're going to write the whole response about. So kind of think about it, plan it out, read the whole thing first. Think about which organism you want to do, and think about what adaptation makes them successful in their environment. They all have a pretty characteristic adaptation. In part B, I want you to think about what variations might have existed in that population before that adaptation became common. So for instance, let me give you an example. So think about our bird example that we had done before all this craziness started happening. We looked at how very minor differences in these birds can lead to very, very big differences over a long amount of time. So we always want to think about what does the original form of the organism maybe look like? Okay, so if all these different varieties of bird could essentially come from one common ancestor, how did we get there? Okay, so we have to think about how the environment influenced the traits that they had. All right, so we look at how all the birds that eat seeds here also have beaks that can crush the seeds, right? So having that bill made them more available to eat seeds, made them more successful in places where there are lots of seeds. The organisms that, can grab things, they eat insects, right? They need to be a little bit more dexterous. They need to be a little bit more careful with their beak. And therefore, the beak that they had, the slight variation that they had, led them to be more successful in an environment that had a lot of insects. Now, of course, our one original organism, they don't all look the same. Just like in our simulation, there might be very small differences. But the environment is going to select one of those small differences as being more successful than others. Okay, so as you fill out this response, that's what you want to think about. What makes the giraffe more successful than other stuff that eats the same things or does similar things in the environment? All right. And you're going to explain how that works, how it got from point A to point B in part C there. In part D and E, you're going to kind of use some information from the experiment to make a prediction about if all those moths lived in environment A for 100 years, for 10 generations, for longer, what might the entire moth population look like in that environment? And how might that be able to be predictable by the data that you have? And then in E, I just want you to kind of very easily sketch your data from part D and sort of show that future prediction model, sort of the way that a lot of these COVID-19 scientists are making future projection models. I want you to kind of think about that. What might happen to this population in generations that we haven't actually made data for? What might happen based on the data we have in the future?